Today we're going to be graphing more polynomials in standard form. The other day we talked about how to graph and factor when we had something x to the fourth power, then an x squared term, and a constant term. And we're going to do that again just to kind of review what we talked about. So I'm looking at this right here, and I noticed that the GCF of these three terms is an x. They all have an x in common. So I'm going to factor out an x, but because my a term is negative, I'm going to factor out a negative x, which will leave us with positive x to the fourth minus 37x squared plus 36. And then I will factor this, this part right here, what is left, using our x box. So x, negative 37 is on the bottom, positive 36 is on top, and two numbers that multiply to positive 36 but add to negative 37, negative 36 and negative 1. And then we do the box, and we put x to the fourth in the upper left and positive 36 in the lower right. And then negative 36 x squared and negative x squared there. And like I said yesterday, the other day, you can flip-flop those. And then you look at the first column and say, what do those two have in common? They have an x squared in common. Then you look at the second column over here, and say, what do they have in common? They both have a 36 in common, but since the top number is negative, we're going to factor out a negative 36. And then on the sides, x squared times x squared gives us x to the fourth, and negative 36 times negative 1 gives us positive 36. So then my factored form will be negative x, well, part of our factor form, negative x times x squared minus 36 times x squared minus 1. Now, we also talked about the difference between putting this in factored form and getting our x-intercepts. I think it is faster to solve these than get our x-intercepts, but sometimes the directions will say to factor completely. So I'm going to factor this completely. So x squared minus 36, that's going to be an x. Our b term is 0, and our c term, or a times c, is negative 36. So two numbers that multiply to negative 36 but add to 0 are 6 and negative 6. So this is going to be x minus 6 times x plus 6. We still have the negative x out in front. Then I'm going to work on this one, x squared minus 1. B value 0. Negative 1 is our a times c term. We have 1 and negative 1 as our two magic numbers. Negative 1 plus 1 is 0, and negative 1 times 1 is negative 1. So then we have x minus 1 times x plus 1. So now our zeros will be x equals 0, x equals 6, x equals negative 6, x equals positive 1, and x equals negative 1. So we just go through it and say what makes each of these factors equal to 0. So now let's go and plot those. So we have negative 6, negative 1, 0, 1, positive 6. Now our leading coefficient was negative. We have negative x in front. So that means the right side's going down. This is a fifth degree function, so the ends are going in opposite directions, so then the left side must go up. And none of our factors here are repeated. There's all these invisible ones. So what that means is that we're going to cross the x-axis at all of these zeros. So just try your best. It doesn't matter how far down and up you go between your x-intercepts, but it is super important to cross your x-axis at all of those zeros. So our end behavior As x approaches negative infinity, the left side is going up. And as x approaches positive infinity, the right side is going down. So this is a good refresher of what we did last time, and hopefully this wasn't too difficult to get through. All right, now let's look at example 2. What you'll notice is that we have 2x to the third plus 12x squared minus 15x minus 90. So we don't have a GCF, and also we don't have an x to the fourth and x squared and a constant, so a term with no x. What happens when we have this, when our exponents go from 3 to invisible 1 and then no x, we go right to the box. Go right to box. So what I mean by that is we're going to draw our box and we're going to fill it in. I say, okay, what goes where? Well, the first one always goes in the upper left, the biggest term, the highest degree. So 2x to the third is the highest term. And the constant with no x's goes in the lower right, kind of like what we've been used to. Now the other two, it doesn't matter where they go. 12x squared can go there, and negative 15x can go here. Or you could flip them. So then we're going to do the same thing we've been doing, looking at the first column and say, well, they don't really have any numbers in common, but they have an x in common, so let's factor that out, x. And then looking at the second column and say, well, what do those two numbers have in common? Well, you can divide both of those by 6. And then we go to the left side of the box and say x times 2x squared is 2x to the third, and 6 times negative 15 is equal to negative 90. So my factored form of this is x plus 6 times 2x squared minus 15. And now we're going to set each of these equal to 0. So what makes x plus 6 0? That's x equals negative 6. Now you may say, well, the one above it, you factored it. Like I said, I think solving it is easier and then plotting those zeros, but sometimes you'll be asked to factor it. So then I'm going to set 2x squared minus 15 equals 0. So add 15. We get 2x squared equals 15. And then we'll divide both sides by 2. And I'm going to leave this as a fraction for now, because I have to square root. I'll square root both sides. This is when I'll get a decimal approximation, because we're going to be plotting these, and it's much easier to plot if I have a decimal approximation from my calculator instead of a fraction that may be confusing to read. So we have 3 zeros. We have negative 6, we have negative 2.74, and positive 2.74. So let's plot those. Negative 6, negative 2.74. So I'm just guessing. It's about there. It's closer to negative 3 than it's closer to negative 2. And then positive 2.74 is closer to 3 than it is closer to positive 2. So then this is a third degree function, so it's odd, an odd degree with a positive leading coefficient, so that means the right side is going up and the left side is going down. And since all of our zeros are different zeros, we don't have any repeated zeros, meaning we don't have x equals negative 6 twice or x equals 2.7 twice. We have negative 2.7 and positive 2.7, which are different numbers. So none of the x's are repeated, so we're going to cross at every x intercept, which makes our end behavior as x approaches negative infinity, y approaches negative infinity, the left side's going down, and as x approaches positive infinity, y is approaching positive infinity, the right side is going up. So the new thing was how to factor, but we have an x to the third power. And we're going to go right to the box when we see that. Right, let's look at the next page where we have a GCF here for this function. We can divide all those numbers by 2, and they have an x in common. So let's factor out a GCF of 2x, and then we're left with x to the third minus 5x squared minus 4x plus 20. And we're going to factor this inside part now. And since we have x to the third, then x squared, then x to the first power, and then 20, we're going to go right to the box. And we put the highest degree term in the upper left, so x to the third goes in the upper left, and the lowest degree goes in the lower right, so the number with no x's, positive 20. And then it doesn't matter where you put the x squared and the x to the first power. So we'll put negative 5x squared here and negative 4x here. And then we'll look at the GCF of the first column. And we say that they have an x squared in common. And we look at the GCF of the second column. You can divide both those numbers by 4, and because that 4 is negative and it's on the top, we're going to factor out a negative 4. And then we'll go through and say x squared times x equals x to the third, and negative 4 times negative 5 is positive 20. So my factored form will be 2x, and then x minus 5 times x squared minus 4. And then we're going to get our zeros from this. From 2x, that is x equals 0, because 2 times 0 gives you 0. From the x minus 5, we get x equals 5. But from x squared minus 4, we have to set that equal to 0 first because it's x squared. Then let's add 4. We get x squared equals 4. And then when we square root both sides, we get x equals plus or minus 2. So we have negative 2, we have 0, positive 2, and positive 5 as our 4 zeros. So let's plot those. Negative 2, 0, positive 2, 5. The leading coefficient was positive. It was positive 2, so the right side goes up. And we had an even degree function, so that means the left side must go up as well, because even degree functions, the ends go in the same direction. And then we cross at every x-intercept because there were no repeated zeros. Okay, so now our end behavior, the left side is going up. So as x approaches negative infinity, y approaches positive infinity. And the right side is also going up, so when x approaches positive infinity, y is approaching positive infinity as well. So this is how the whole thing should look. All right, now let's look at this last problem here. So let's look at these terms, and we can factor out an x to the third power because they all have that in common. And since our leading coefficient is negative, I'm going to factor out a negative x to the third So that makes factoring a bit easier. So we're left with 4x to the third minus x squared minus 4x plus 1. Because remember, when you factor out a negative number, all of your signs will change from negative to positive or positive to negative. So we are now left with this to factor. And because we have an x to the third and x squared and x to the first power and no x at all, we go right to the box. Upper left is going to be our 4x to the third. Lower right will be your positive 1. And then it doesn't matter where you put the other 2. Let's do negative x squared and negative 4x. We look at this first column. The GCF here is 4x, so that's going to go on top. We look at the second column here. Our GCF is 1, but since our top number is also negative, it's going to be negative 1. And then we say 4x times x squared gives us 4x to the third, and negative 1 minus 1 gives you positive 1. So our factored form is going to be negative x to the third, because that's still there, times 4x minus 1 times x squared minus 1. And then we have to set each of those equal to 0. Negative x to the third, that just means x equals 0. Then 4x minus 1, we set that equal to 0. We'll add 1. We get 4x equals positive 1. And then when we divide both sides by 4, we get x equals 1/4, or 0.25. That might make it easier to plot. And then we have x squared minus 1 equals 0. We'll add 1 to both sides. X squared equals 1. And then when we square root everything, we get x equals plus or minus 1. So we have a 0 at negative 1, at 0, at positive 1/4, and at positive 1. So let's go ahead and plot those. Negative 1, 0. Now 1/4 is going to be closer to 0 than 1, and then positive 1. Okay. Our leading coefficient was negative, which means the right side will go down, and our degree, you can either go back here, I mean, in factored form, this is not completely factored form. So you can't just add up, 3, 1, and 1, because here in this last factor, we have an x squared in it. So what I would do is I would look at the original that we started with and say, my degree is 6. That's an even degree, so that means the ends go in the same direction. So if the right side goes down, so does the left side. And we have no repeated zeros, so we cross at each one. So your graph will look something like that. And then we do our end behavior. Okay, the left side is going down, so as x approaches negative infinity, y approaches negative infinity as well. And our right side does the same thing. As x approaches positive infinity, y approaches negative infinity as well. So this was all about putting things that we learned together to learn how to factor in another way. So this is why factoring was super important, because we needed to be able to find the GCF of some terms. So all those things are building upon one another. So it's important that if you need to go back and review something, do it now, because if you wait until we build off of it and you don't have that solid foundation, you're trying to build your knowledge on a foundation of sand, and once the sand gets blown away, then everything comes crumbling down. So I hope that this was a good video to learn how to factor when we have cubic functions or third power functions. So thank you for watching. Make sure you like this video and subscribe.